Hello everyone! Today I'm presenting my Arduino project, a two-way traffic light system with left and right turn signal and pedestrian crossings. This setup controls vehicle movement from north to south, allowing cars to go straight, turn left or right. It also includes pedestrian crossing signals on the east and west side, actuated by push buttons. The project simulates a real-world intersection using Arduino, LEDs, and buttons to manage traffic flow and pedestrian safety. Let's talk about the concept. The idea is to create a safe and automated intersection. The real-world traffic must be carefully controlled to avoid accident, reduce congestion, and provide safe access for pedestrians. This project model are basic but realistic version of such a system using Arduino. Here are the three key concepts behind the design. First one is movement control. Vehicle movements such as left turn, go straight, and right turn are handled to avoid collision between different types of traffic. Second one, pedestrian crossing safety. Pedestrian crossing safety is our main goal in this one. Pedestrian press a button to request crossing. The system waits for the current vehicle phase to complete, then activate the green pedestrian light. This is to ensure pedestrian never cross while vehicle is moving. Third one, coordinates vehicle movement without conflict. Vehicles from both north and south directions are allowed to move at the same time. But the system ensures that no movement overlaps in a way that could cause a collision. Next, let's see how it looks. The system is wired on a breadboard and everything is controlled by Arduino. Each direction, north and south, has its own set of traffic lights for left, straight, and right movement. The straight signal and right turn signal for both directions are controlled together since they follow the same logic. The left turn signal are wired separately and are linked to pedestrian light using reverse red and green wire. This means when cars cannot turn left, pedestrians are allowed to cross, making sure the two actions never happen at the same time. There are 4 pedestrian buttons, 2 on the west side and 2 on the east side. The buttons on the left side are wired together and the one on the right side are wired together. These buttons are connected to Arduino pin 2 and 3, which are interrupt capable so the Arduino can respond immediately. This is the full pin layout. First one, left turn from the north plus pedestrian light is pin 0, 1, and 4. Button is on pin 2 and 3. Right turn from direction north and south is pin 5, 6, and 7. Straight signal from north and south, pin 8, 9, 10. Left turn from south direction plus pedestrian light, it's pin 11, 12, and 13.
Hello, welcome to the code part. Start with part 1, setup part. We set the pattern at pin 2 and 3. Set go straight at pin 10, 9, and 8. Set right turn at pin 7, 6, and 5. Left turn in the north side at pin 4, 1, and 0. And the last one, set left turn in the south side at pin 13, 12, and 11. We create the time array named delay array. Inside the array, it has 30,000 mean 30 seconds for green light, 3,000 mean 3 seconds for yellow light, and the last one 30,000 for the red light. Next, in the line 11 and 12, we set the button for left side, north and south are false. In the method setup, we set pin 2 and 3 are input because 2 and 3 is the buttons. other pins are output and set it low. Then we set high at pins low 5, 8, and 11, which are the pins for red lights. Part 2. Interrupt part. In the line 30 and 31 are interrupt for the buttons. While button L is pressed and while button L in press mean change from false to true. Part 3 is main loop. We have only two main functions. First is the function for go straight and turn left. In this function has the button interrupts. That means in this function you can cross the road. And the second is for turn left and turn right, no crossing the road. After this will be the four conditions that are in the straight and left turn. Condition 1. Situation where both the north and south buttons are pressed. If I equal to 0 means I is the crossing light is green. Then set straight pin to low means red light is off. Set left turn north and south pin to high means red light is on. And then set straight pin I equal to 0 high means green light is on. Set left turn north and south pin I equal to 0 low means green light is off. Set delay equal to 20 seconds. After 20 seconds, set the buttons to false. The red lights on the left, north, and straight are off. Then green lights on the left, north, and south, and straight are on. Of this delay 10 seconds. Else in the line 71 means yellow and red lights. For example, yellow is I equal to 1. Line 72. Set straight pin I minus 1 low means green light is off. Line 73. Set straight pin I high means yellow light is on. If I not equal to 2 mean the lights are green or yellow. Use the delay array that we have created. Condition 2 is the only south button is pressed. In this condition, the code is the same like condition 1, but has only the south button. Next to the condition 3, the code is still same like the condition 1, but has only the north button. Last condition. There are no buttons to press, either north or south. So just change green to yellow, yellow to red, and group it continuously. Finally, we reach the last part. The last part is right-left turn function. If I equal to 0 mean the green light, we set right turn, left turn north, and left turn south pin 2 are low, means the red lights are off. Else mean the yellow and red lights. Set right turn I minus 1 is low. For example, yellow is I equal to 1 means the green light is off. Then we set the right turn I is high and use the delay array that we have created.
I'm going to show you 4 examples of how it works. Me and my friend trying to visualize it in the most simplest form, so hope you guys enjoy. Let's see the first one together. At the start of the cycle, turn left and straight for both north and south direction turn green. Allow vehicle to go straight or turn left. The right turn remained red during the phrase to avoid conflict. After a few seconds, the straight signal turned red, but since no pedestrian button is pressed, the left turn signal remained green continuously. Then the right turn turned green, so both left and right turn lights are green at the same time. The pedestrian lights stay red because no one requests to cross. Once the right turn phrase ends, the cycle repeats. The right turn signal turns red and the straight turns green, and the loop continues. Throughout all of this, the left turn signal stays green by default until pedestrian press the button. Hope you guys still with me. And are you ready for the next example? During a normal cycle as an example 1, someone pressed the pedestrian button on the both left and right side, you can see. The Arduino detects the using interrupt pins but does not stop traffic immediately. It waits for the current phrase to finish. Once the cycle ends, left turn and right turn lights turn red. Straight lights turn green. The pedestrian crossing lights turn green to allow safe crossing from both sides. And after a few seconds, the pedestrian lights turn red, and the system returns to its normal vehicle sequence. This is to ensure pedestrians only cross when no turning vehicles are active, keeping the intersection safe. Okay, let's see the third example. A pedestrian pressed the button on the left side of the crosswalk. The Arduino detects the request through the interrupt. But just like before, it waits for the current vehicle cycle to finish. Once the cycle ends, left turn and right turn signal turn red, straight signal remain green, the pedestrian lights on the left side turn green, allowing pedestrian to cross. But on the right side, pedestrian lights remain red because no request was made from that side. After the few seconds, the left pedestrian lights turn red, the system returns to regular traffic loop. This allows one-side pedestrian crossing without interrupt or activating unnecessary signals. Let's move on to the last one. During an active pedestrian crossing phase, the pedestrian light is already green, right? But if someone pressed the button again while the light is still green, it's nothing happened. The system ignored the input since the crossing signal is already active. The system continues running the current pedestrian phase as usual, and when it's end, it moves on to the next traffic cycle without being interrupted. This prevents unnecessary delays or repeat crossing trigger while pedestrians are already walking.